Hi everybody, this is Mr. V here, and this is our lesson for Friday, January the 8th. And again, I'm recording this because I'm out today, but I'm going to give you all the instructions that you need. You're going to need your math journal today and the electronic copy of this worksheet that you see right here in this video is posted in my modules. And so you won't need a paper copy like I have here, but I'm just going to use a paper copy right now because it's easier. But I want you to do two things. I want you to open the electronic copy of this worksheet that you see, because what we're going to do is we're going to look at the problems on the electronic copy, and then we're going to show the work in our journal. I think it'll just work out a lot better if we do it that way. So I'll give you a second, pause the video if you need to open up the electronic copy, to have it where you can go back and forth between that and your journal. We're going to work on expressions and equations practice, very similar to yesterday, but we're going to dive in a little bit deeper to solve some problems on your own today. We're going to do 6 examples together, and I want you to take really good notes while you're doing it. And then you can use these notes to complete a Canvas quiz. After you watch this video, you can go and complete a Canvas quiz, an assignment for a grade on your own that have questions that are very similar to these. So let's get started. On your journal, I'm just going to give these questions. I'm going to use these same question numbers so I know which one I'm on. I'm going to stay organized in my journal. So the first thing that I'm going to do is this is just question number 1 from our practice here. And it says, Mrs. Jacobson asks each group of students to write an expression equivalent to the model below. And so we've got our model drawn right here, very similar to the algebra tiles that I showed you in class yesterday. It says the table shows the group's expressions. So group 1 thinks that the expression should be this. Group 2, group 3, and group 4, they each have what they think the expression should be, and we're trying to figure out which group was wrong, or which group had something that was incorrect, as you see here. Okay, so keep in mind that we are looking for the answer that is not correct. So we're looking for something that's not equal to what we have in this picture up here. So in our journal, kind of taking notes of what we see here, these are the things I want you to notice. You have in your model the same thing repeated 3 times. Okay, you have 1x, 2x, 3x, 4x, and then you have 1, 2, 3, positive 3. So here's what you have repeated. You have 4x plus 3 in just this picture right here, or just this part of the picture. And then you have an additional one of those. So I'm going to say plus. I have an additional copy of that same thing. I have another 4x plus 3. And then over here on the end, I have another copy of that. I have another copy. So an additional 4x plus 3. And so you can see really quickly that there is one group that has this very same expression, group number 4, 4x plus 3 plus 4x plus 3 plus 4x plus 3. So I'll put a little check mark by group number 4 because we know that that is one way to represent what's going on. If we were to rearrange these tiles, if they weren't organized the way that they are, we could count them in a different way. We could count all of the X algebra tiles. And if we did that, we could say, all right, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 X's. 12 times we counted an X. So we could say 12X. And if you look up above, you can see where that comes from. 4X plus another 4X is 8X. And 8X plus another 4X would be 12X. So we could also start out by doing it like that. And that means we could group the positive ones all together in the same way. So 1 plus 1 plus 1, 1 plus 1 plus 1, 1 plus 1 plus 1, 3, 6, 9. So 12x plus 9 would be another way that we could write that. Now that's not listed as one of the choices down here. So we're going to have to do a little bit more thinking or investigating about what these other groups went with. Okay, so since that's not listed, let's start to look closely at what is. So we've already got two ways of writing it. Let's take a look at what these other groups have chosen to do. Okay, let's start with group number 1 here, and let's think about what group number 1 is saying. Okay, so in my notes over here, I know that this is okay, and I know that this is okay. What I'd like to do is check group 1. So I'm just going to write down group 1, and I'm going to write down what it was that they wrote. They wrote 3 times 4x, 3 times 4x like this, plus 3 times 3. And I want to know if that is a good way to write what's going on in this same picture. So let me think about what's going on here. Let me just solve it, okay? If I want to multiply this, well, I could definitely start with, I know what 3 times 3 is, so let me just bring everything else. I'm going to switch colors here. Let me just bring everything else down. 3 times 4x plus, I'm going to go ahead and say 9, okay? 3 times 4x plus 9. That makes sense because I know that there's a positive 9 going on anyway, because that's one of the ways that I could write it over here. So that makes sense, but I'm not sure what's going on with this 3 times 4x piece here. So let me play around with that for just a second. If I try to solve and try to multiply this, you have to think about what a letter next to a number really means. It really means multiplication. So since this is 4 times x, and you're also multiplying that times 3, what you really got is 3 times 4 times x plus 9. Okay? And so now we can start to pull this apart, and we can go, okay, well, I know what 3 times 4 is. 3 times 4 is 12. And 12 times x is just 12 times x. Because I don't know what x is, I can't go any further than that. And here's my plus 9. And so look at what we've got here. We found a match. 12x plus 9 here. And we also agreed that 12x plus 9 is one of the ways that we could write that. And so since this is equal to this, and this is equal to this, and this is equal to this, that means that group 1 does have a good way that works so that we could write this. So it would come down here to group 1, and we would say, even though it doesn't look the same, we've tested it out, and we see that it is. Okay? So now let's talk about what group 2 is doing. So here we come down here, let's organize and say, all right, here's what group 2 is doing. Now, it should go without saying that if I'm writing this in my journal notes, this is what you should be writing in your journal notes. Just sitting here watching the video is not good enough. I want you to be going through along with me, just like you would on a normal day in class. Group 2 said 4 times x, and that's going to be times 3 plus 3 plus 3. Okay? If we were to follow the order of operations, we can solve a little bit of this, not all of it, but we can look inside the parentheses, and we can say, well, 3 plus 3 plus 3 is 9, so this has got to be equal to 4x times 9. And here's where I see a huge mistake. We're multiplying by 9 here, but we're supposed to be adding 9, whether you're doing it like this, plus 9, or whether you're doing it in 3 separate pieces, plus 3, plus 3, plus 3. We should be looking for an expression that's adding 9, not an expression that's multiplying 9. And we only have 4x. This picture doesn't have just 4. It has 12 total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4x is not enough to represent that picture. And although we do have 9 positives, we're not multiplying by them. So I think we can see that group 2 is not giving us an equation or excuse me, an expression that's equivalent to what we see in this picture, okay? So for right now, I don't think 2 is doing a good job of creating an expression that matches the picture. So let's look at the last one, and this is group 3's. Group 3 says 3 times 4x plus 3, okay? So we're going to take a look at this and go, okay, how can this match what's going on in this picture? You have to think about what all of this means, okay? This is multiplication. Parentheses next to a number is multiplication. So what we're doing is we're multiplying 3 times everything that is inside of these parentheses, okay? I'm multiplying 3 times 4x, and I'm also multiplying 3 times the positive 3. 3 copies of that. That's what that's saying. 3 of them. That's the exact same thing, ladies and gentlemen, as saying 4x plus 3 plus another 4x plus 3 plus another 4x plus 3. That's what 3 times means. It means 3 of them, 3 copies of what's inside this parentheses. And now it doesn't take long at all to see that group 3 has something very similar to what group 4 had, which was 4x plus 3 plus 4x plus 3 plus 4x plus 3. These parentheses can kind of be dropped off now because these two are copies of each other. And if you want to think about this another way, you could do it like this. You could say, if I got to multiply 3 times everything inside of those parentheses, well, if I do that separately, if I do 3 times 4x, 3 times 4 is 12. And we're also multiplying that times x. So 3 times 4 is 12. Then there's your x. And then 3 times positive 3 is positive 9. So there's 12 times x plus 9, or you could drop that symbol out of there. There's your 12x plus 9, which we already know works up here. So group number 1, group number 3, and group number 4, they were correct. It was group number 2 that was incorrect. So since you don't have the printed out paper, would you write this for me? Let's just say group 2 was incorrect. Okay, and we've solved a pretty hard problem by going through the steps and really thinking about equal ways to write the same thing. Okay, so the good thing about this being a recorded video is you can pause this and go back as many times as you need to kind of see how we thought through this problem. Okay, all right, let's take a look at number 2. I used this today in some of my classes. I used this 2g plus 6, but that's okay. I might have called it 2x plus 6, but I'm going to use this problem again. It's a great problem. I didn't use all the answer choices, so it should look like a new problem to you. It says, which of the following is true for 2g plus 6? Now we've got some choices here. Is it representing an equation? Are there multiple possible values for g? Is it representing an expression? Is there only one possible value for g? This is a really easy question. Let's organize our journal here. So for number 2, I want you to just write 2 times g plus 6. And after the lesson that we did before, you should really already know what's going on. There is no equal sign in this. So this is definitely an expression. It has to have an equal sign, and it has to have an answer in order to be an equation. So it's definitely an expression. I can already rule out a couple of answer choices. This says representative of an equation. No, it's not. It's representative of an expression. So this one is correct. This one is not. Now that we know that it's an expression, we know directly from your notes that we took, we wrote down that expressions have multiple possible values for the variable. That means G could be anything, okay? Could be any value. Write that down in your notes. We don't have an equal sign with an answer to help us solve this any farther. That G could be 2 times 1 plus 6. That could be 2 times 9 plus 6. That could be 2 times negative 4 plus 6. Without an equal sign and an answer, there is no way for us to know. That means that there are multiple possible values of G. So when I come over and I look at these, it says it right here, multiple possible values for G. The last one says only one possible value for G. That is incorrect. That happens when it's an equation, and it's definitely not. So 2 and 3 are what we're looking for. That looks to be like answer choice H. So what I would say, I would just say 2 and 3 only, if you want to write down what the correct answer was. And if you want to, you can say that that was answer choice H. Okay. And the first one we did, that was answer choice B, if you want to record what answer choice on your journal paper. So that's a pretty easy question based on our notes that we already took. All right, let's keep going a little further with this. Next question says, Nia plans to give 1 necklace and 1 sparkle pen to each girl who attends her birthday party. Necklaces cost $4 each and sparkle pens cost $2 each. She uses the expression 4 times G plus 2 times G to calculate the cost in dollars of the gifts for the girls attending the party. Which of the following is equivalent to Nia's expression? So let's start with the original expression first. Let's start with organizing this. Here's number 3. The original expression that she used is 4 times G plus 2 times G. So we've got some choices here as far as what the correct answer may be, but before we even look at these, I want to do a little drawing like we did yesterday. Now, yesterday we did X's, but today the variable is a G. So here's what we're going to do. I'm just going to draw a quick little model, just like we did with the algebra tiles yesterday. So this time I'm going to use G instead of X. So 4G means I need to have 4 of these. I'm going to quickly draw 4 of them. There's 4G right there. This picture goes with this portion of the expression. Now, adding means I'm physically going to add to the paper 2 more of them. There's another G, and there's another G. So no matter how you think about this, ladies and gentlemen, there's a total on this paper right here, a total of 6 times G, 6G. 1, 2, 3, 4, 5, 6. Okay. If we look over here at our answer choices, that is hanging out right here. Answer choice B, 6G. Now let's take a look at why the others are wrong before we just go on and say definitely B is correct. It is. Let's take a look at why the others are wrong. When you take a look at over here, I mean, look at this answer choice, A. G plus G, think about that for a second. G plus G would mean I would have an algebra tile like this and an algebra tile like this. That would be 2G, okay? So if I take those 2 things and I'm adding them together, what I would be saying here is 6 times 2G. 6 times 2G is not the same thing as 4G plus 2G. They don't look the same at all, okay? You would multiply these and you would have 6 times 2 is 12. You'd have 12G. That's not what the original problem has at all, okay? 6G squared, okay? I'm not sure why you would do that again. 6G squared means you have 6G times another 6G. That's what that expression is equal to. We learned about exponents already, so that should make sense. We don't have 6G times 6G. We have 4G plus 2G. That was the original expression. And the last one, 8G, is just incorrect. 8G, there's not 8 of them. When you go with the original expression and you draw it out in a model, there's not 8 of them to begin with. So maybe that gives you a few reasons why these other ones are wrong. So the thing that I'm getting you or wanting you to understand here is sometimes drawing that model based on the expression they gave you makes it really easy to decide what the answer may be. All right, we're going to keep going here. I'm going to go to the next clean page because I'm running out of room on there. And this will be number 4. We're almost finished with our examples, and then we'll let you try some on your own. This is number 4. It says, Megan tries to convince her classmate Fiona that 2x plus 3 equals 10 represents an expression. Fiona disagrees and thinks that it represents an equation. Who is correct? Well, the key to this is right here. We learned this already, that if it has an equal sign and it has an answer, then it cannot be an expression. It has to be an equation. We even had one of my students, Jonathan, point out that the word equation almost has the word equal in it, which is why we need to have an equal sign when we're using equations, not expressions. So obviously, this says Megan is correct because expressions contain variables. Well, Megan is wrong, first of all, because it says Megan tries to convince her classmate Fiona that it's an expression. So first of all, Megan is wrong. But both expressions and equations contain variables. So that's not a really good way to justify your answer there. But either way, Megan is not correct. She's definitely incorrect. The next one says Fiona is correct. We know that's true. Fiona says that it's an equation. So we know that Fiona is correct. But let's look at her reasoning. Her reasoning says because equations always contain an equal sign. That's true. That's what we've learned. Okay. So G is probably what we want. Let's continue to make sure. Both girls are correct because expressions and equations are the same thing. No. Question, they are not the same thing at all. Okay. We learned that. And the other one says neither girl is correct. And we know that that's not right because we already know Fiona is correct in what she has said. So not a whole lot of work to show on number 4. On number 4, I would just say Fiona is correct. And I would say 2x plus 3 equals 10 is an equation. And again, it's right here. It's because it has an equal sign with an answer. That's why it's an equation. Very easy question right there. Okay, let's keep going. We only have 2 more to look at, and then you're going to answer some questions on your own. This is question number 5. This one says, Kareem and Natalie each created an expression using the models below. Here's Kareem's expression. Here's Natalie's expression. What would Natalie need to add to her model? So what would we have to add to this model over here for it to be equivalent to Kareem's model? So some of you might be freaking out a little bit going, oh my gosh, they're triangles instead of rectangles. It doesn't make any difference, okay? We can still use these models. Let's talk about what we have first, okay? Before we try to figure out what to add to this one, let's know what we have, okay? What would Natalie need to add to her model for it to be equivalent? So meaning, if we want these 2 things to be equal to each other, they're not right now. So we've got to figure out what's going on with them. So let's look at each picture. The first picture, we have x or 1x, okay? There's one of them, so 1 times x. We have positive 1, positive 2, positive 3, so 1x plus 3, and we have 2 negatives, so minus 2. You could say 1x plus 3 minus 2. You could say 1x plus 3 plus negative 2. We talked about this yesterday, that these 2 things are the same, so 1x plus 3 plus negative 2, that's the same thing as this down here. And over here on the other side, we also have 1 times x, because there's only one of them, but we have plus 4. So in order to make these things the same, we're going to have to solve Kareem's a little bit. We're going to have to do the 3 minus 2 in order to see what we've got. So if we take care of that and solve this piece right here, this 3 minus 2, what we would get for Kareem, I'm going to try to organize this as best I can. Actually, I should be doing it over here on this paper. So let's do that. Forgot that you guys don't have the paper copy of that. Here's what I'm going to do. Let's back up a little bit. Sorry about that. Please go to your journal paper. I want you to write 1x plus 3 minus 2 for Kareem. And over here, I want you to write Natalie. And I want you to write 1x plus 4. And I'm just taking that straight from the picture right here. Okay. Now, I want to add something to this in order to get it to be equal to this. Right now, they're not equal. So I'm going to solve this a little bit further. I'm going to say, let me do 3 minus 2 and see what I got. I've got 1x plus 3 minus 2 is 1. And I want these two things to be equal. So right now, they're not equal. Even right now, they're not equal. So let me bring this one down side by side. 1x plus 1 is obviously not the same as 1x plus 4. But if I came over here to this side and I did this right here, if I added 3 positives to this positive right here, then I would have 1x plus 4, and then it would be equal to 1x plus 4. So adding positive 3 made them equal. They were not equal before, but now they are. So when I go back and look at this picture, this would be adding positive 1, this would be adding negative 2, this would be adding negative 3, this would be adding positive 3, and that would balance it out and make the two things equal. Matter of fact, if I did that, you could see if I came over here and I did, let's try to fit all this into the picture. If I did plus 1, whoops, plus 1, and another plus 1, okay? Now I've got some, remember, negatives and positives are going to cancel each other out. So I've added my 3 positives. Now let's cancel things out. A negative and a positive cancel each other out. A negative and a positive cancel each other out. And the only thing that I have left is 1, 2, 3, 4 positives. Right here they are, 1, 2, 3, 4 positives. And here's 1, 2, 3, 4 positives here. So 4 positives and an x, 4 positives and an x. So adding positive 3 to that equation, to Kareem's expression, made those two expressions equal to each other. Okay. In this problem, we were looking at answer choice D, and I'll just say adding positive 3. That's what made them equal. Okay. All right, last one, and then you're going to be trying some on your own. Here is number 6. Which of the following does not represent an equation? Not an equation. Okay, not an equation. So we have to really think about what's going on here. So here we go. We're going to be organized again. Last one we're going to do in your journal, number 6. And I'm going to have you write these. I want you to write them out. The first one says, first one is answer choice F. The first one says, twice a number is 6. Twice a number is 6. You have to think about what twice means. Twice means 2 times. Okay? So 2 times a number, let's just say n for some random number that we don't know. 2 times a number is, we learned this, is means equals 6. 2 times n equals 6. Twice a number is 6. You could even do this and group them like this. 2 times n equals 6. Remember, the question says which one does not represent an equation. This one is an equation because it has an equal sign and an answer. Okay, so F is an equation. We're looking for one that's not. Answer choice G. X plus 6 equals 10. I mean, do we really need to talk about this one? Which one does not represent an equation? This is an equation because it has an equal sign and an answer. So again, we're looking for the one that does not. This one definitely is. 2 more to go. Answer choice H, 6 years older than Mike. 6 years older than Mike. All right. So here's Mike. Mike is M. M represents Mike. So how do you get 6 years older than Mike? You add 6 to however much Mike is. This sentence doesn't have an is in it. It doesn't have any more information. All we can make with this is an expression. And an expression is not an equation. We're looking for the one that is not an equation. So I can tell you right now that I think it's going to be answer choice H because this is not an equation. Obviously, we're going to be thorough here and finish it out. J, negative 9 plus 2 equals negative 7. This one is an equation because, again, it has an equal sign and an answer. So not too hard of a question right there. You just need to go along with each answer choice and make sure you're paying attention to what the question is asking. And this one wanted something that was not an equation. Okay. Again, go back and look through this video as needed over each of the 6 questions that we talked about. Hopefully you took good notes. And by taking those good notes, it's going to allow you to do the next step, which is to complete a Canvas quiz on your own over the same types of questions. So if you need help, you can ask Miss Hanson if you're in class. If you need help and you're online today, you can send me a message, but I probably won't be able to get back with you until Monday. But good luck, guys, and I will see you guys back soon. Thanks for watching, and go complete your assignment. It will be for a grade, even though I'm not there today. So go take care of your assignment, and we'll see you guys soon. Thanks for watching.